Here are the solutions and points for the free response question I assigned on Friday. So if you weren't sure how to do this problem, please make sure you just follow along right now. And then again, keep going back over the problem over the next week. So we're definitely allowed to use a calculator here. So what we want to do is go to the define feature, menu 1.1, and we want to define R of t, and then just type in this expression very carefully. I usually put a multiplication dot. I hit the key right in between. Sometimes it accepts it, sometimes it doesn't. But we want to define R of t. It saves time instead of having to always type that expression back in. So R of t is the rate at which people enter a line for an escalator. And it's equal, this is a piecewise function, so it's equal to this top expression for all t values between 0 and 300 inclusive, and then R of t is equal to 0 for any time over 300. So again, R of t is measured in people per second, t is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. There are 20 people in line at time t equals 0. So question A, how many people just enter the line for the escalator during the time interval from t equals 0 to 300? So here's that fact again from the handout, the written handouts that I gave you guys. We would say like the total accumulation of people in line would just be the integral from 0 to 300 of R of t dt. So all you have to do is type this in, hit that variable key to pick that R of t function. And once you type that in, you should get 270 people. So you get 1 point for the integral. I still would always label it 1 point for the answer. All right, now for part B, it says during this time interval from 0 to 300, there are always people in line for the escalator. How many people are in line at time t equals 300? So just to be a little bit more specific, we'll say accumulation of people entering the line. Because B is going to be done a little different. This is the total accumulation of people in line. So we know there's already 20. Then we would still have the integral from 0 to 300 of R of t dt, which was the 270. So you could write that there as well. But then people are also exiting. So we're going to take that rate away. There's two ways we could do this. We'd say the integral from 0 to 300 of 0.7 dt, or really this just becomes minus 0.7 times 300. So it might make sense that way. Because if you recall, and the way I'm going to write this just makes a little bit more sense, is distance is equal to rate times time. So distance would be like our total accumulation. So here's our rate times our time. So that's another way to look at this. So all you'd have to do now is type that into your calculator. And we should get 80 people. So 2 points for this one. 1 point, I would say, for the entire integral, but they make a special mention to make sure that you subtract the rate that they're exiting the line, and then 1 point for the answer. All right, now part C really isn't calculus based. It's just based off of that, the model of like distance is equal to rate times time. So for question C, for t greater than 300, what is the first time that there are no people in line for the escalator? So we're looking for time here. So we know 300 seconds has passed. And again, if I look at distance is equal to rate times time, or total amount of people in line is equal to the rate times the time. I'm looking for time here, so t is going to be our total amount divided by r. So after 300 seconds, the way we're going to figure out the time is to take the total amount of people in line at t equals 300, which was 80, and divide it by the rate that they're exiting, which is 0.7. And this gives us about 414.286 seconds. So this is the time. This is our first 300 seconds, plus the time it takes for those to exit afterwards. So right now we've got 80 people in line at 300 seconds. We know nobody else is getting in line after 300 seconds, so we just divide that 80 by that 0.7. And that's only 1 point there. So right now we're up to 5 points. The last part is a little bit more involved, but this is where you could get your four other points. All right, so for question D, again, for time t's between 0 and 300, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time and justify our answer. So again, let's go ahead and write this out. The total number of people in line at time t, where t is between 0 and 300, is going to be that 20 plus, I have to change this a little bit, the integral from 0 to t, we'll call this r of x dx, and then minus, again, the integral from 0 to t, or we could just put that 0.7t. So that's exactly what we did in part B, only we were given the 300, so we could put the t back over here. So that's our function. I'll just call this kind of like p of x, total number of people in line. I'll avoid a variable here. We'll just call that p for the total number of people. So now we want to find the derivative. Derivative of a constant is just 0. Now here's that first part of the fundamental theorem of calculus. If I took the derivative of this antiderivative, this would just leave me with r of t. And then the derivative of this last term is just minus 0.7. So you get 1 point for getting to this part right here. Now we want to set it equal to 0. So we'll take r of t minus 0.7 equal to 0. Now you want to use the solve feature on your calculator. Remember, choose r of t function that you defined. Make sure you put comma t after the equals 0. So pause the video to do that before I show you the two t values we should be coming up with. All right, so first we'll just round to 3 decimal places. Should be t equals 33.013. The other one, t equals 166.575. Well, we're looking for a minimum, an absolute minimum here, because we're on a closed time interval, so we could use the extreme value theorem and make a table. So we'll have our values of t, and then we'll have, call that p of t then. That's what this is. And we have 0. We have our first time, which was the 33.013. Then we have the 166.575, and then we have the 300. Well, we know when time t equals 0, we had 20 people in line. So now you want to go back and you want to use this function right here, type this in when t is equal to 33.013. Now when you get to this part, you're going to have the integral from 0 to 33.013, and you can still do r of t dt. But pause the video to calculate these others. We know at 300 there were 80. And pause the video if you still need more time. But when t is 33.013, we should be getting 3.803 roughly, and then a 158.070. So clearly this is the lowest value. This is the min, so we want to answer this now. So we would say the number of people in line is a minimum. I'm just abbreviating here. At t equals 33.013 seconds. when there are, it said to round to the nearest whole number here, so we're very close to 4, when there are 4 people in line. Now you could phrase this anyway. You could say the minimum number of people in line is 4 at time t equals 33.013 seconds. But 4 points for this. You got 1 point for figuring out this derivative here, setting it equal to 0. 1 point for finding the time values. 1 point for the answer, and then we would call that the justification. So practice this problem a few more times. Let me know if you have any questions.